Welcome back to another Algebra 2 video. I am Mr. Hibble. Today we're looking at solving some quadratics. One thing to remember is a quadratic is x squared is your largest term, right? Where the 2 is your biggest exponent. Okay, those are quadratics. The rest of this unit, we're going to be solving these quadratics. The first method we're going to be using, let's look at a few problems. I have x squared minus 9, x squared over 3. I have 2x squared plus 24. Right? And one thing you'll notice about each of these equations is there's only a singular x variable. Because there's only a single x, what that tells me we should do is we can get that x by itself. One variable, always isolate it. It's generally the easiest method. So what that means is you just need to move everything to the other side. For example, if I have x squared minus 9, I could solve this like normal, where I add 9 on both sides, giving me x squared equals positive 9. And it might look like x is by itself, but right now it's x squared, so I get rid of that squared. To get rid of something squared, I need the opposite of squared. So we think back a little bit. What is the opposite of squaring something? The opposite of squaring something, the inverse of a square, is a square root. Squares and square roots cancel, just leaving me with the x. One weird thing happens when you take a square root on both sides of an equation. We know the square root of 9 is 3, right? Because 3 times 3 is 9. But that's not the only number multiplied by itself that gives you 9. We know positive 3 times positive 3 is 9, but what if you did negative 3 times negative 3? Well, the negative times the negative would cancel, still giving me positive 9. So whenever you take the square root of both sides, one thing that will always happen is you will get plus or minus. That's what that little symbol is called. X equals plus or minus 3. Really what that means is you have two answers. X equals positive 3 or x equals negative 3. It can be either of those values, okay? We do represent both answers generally. Looking at this next one then, it's x squared over 3 equals 15. So get rid of the 3. The 3 is being divided, so I use the opposite of division, and I can multiply by 3 on both sides. X squared equals 45. Take the square root of both sides to get rid of that squared, right? Squares and square roots cancel. Do that with the 45. Remember, you cannot forget plus or minus, or you're going to get both these values. But the square root of 45 does not simplify nicely. There is not a number times itself, a whole number at least, that gives us 45. So what we need to do then is, okay, we need to find a perfect square that goes into 45. So if you need to watch our video, the other 3.3 video, simplifying square roots, please do that. But what you would end up finding is 9, a perfect square, does go into 45. It goes in 5 times. The square root of 9 we know is 3. The square root of 5 we do not know, that is 5. And we have our final answer, positive 3 root 5, as well as negative 3 root 5. We get 2 answers there. Let's look at another few problems here. Okay, this one can get maybe slightly more challenging. You still just need to get the x by itself, so I subtract 24. It's 2x squared equals negative 24. Before you can take the square root, some people would want to do that on this step. Before you take your square root, you want to get that squared thing by itself. The 2 is not being squared, it's only multiplying with the x. That is being squared, so we can get rid of that too, giving us negative 12. Get rid of the squared by square rooting. Don't forget your plus or minus. Okay, but remember from the last video, we don't like negative square roots, so I'm going to make this 12 positive. But if you change your square root to be positive, that means that you must be making the imaginary number. In order to change your square root from a negative to a positive, you need to include the imaginary number I. Once you do that, you could see if the square root of 12 simplifies at all. So I'd want to know if there's a perfect square that goes into 12, and I actually believe 4 goes in 3 times. Take the square root of the value that you can. The square root of 4 is 2. You can put that in front of the I technically because it's not in the square root anymore. The square root's generally the last thing in these statements. That would be our answer for that problem there. Looking at 2 more problems, here's the next one. Notice we have these parentheses, and just like we were doing, I would still try and get the x by itself. The way that we got x by itself on all of those other problems was just by getting rid of everything, moving everything. So I'm not really going to do too much here. I'm just going to move the 19. X minus 2 squared is equal to 9 now. And this is where most people make their mistake on this problem. I have x minus 2 being squared, and some people want to try and distribute the squared. Well, that doesn't work. We're going to talk about how to square binomials or square parentheses in Unit 4, so I don't want to talk too much about that right now. But if we're solving, we're doing the opposite of everything. So if I want to get rid of something squared, why don't I just take the square root of that and do that to both sides? The square and the square root go away, so I just have the x minus 2. The square root of 9 is positive and negative 3. And now I could get x by itself. In order to do that, though, notice these parentheses. Some people write those parentheses down on this step because they saw them on the line before, and that makes sense. That's fair. But notice there's nothing outside of those parentheses. The squared is gone. There's nothing multiplying with them. So I actually don't need the parentheses anymore on this step. Get the x by itself, add the 2 over. Again, this is a weird spot now because I have plus or minus 3 plus 2. What the heck do we do with that? Well, whenever you have plus or minus and you're adding or subtracting something with that, right? I'm adding 2 to the plus or minus 3. We generally just put that value in front of the plus or minus. 2 plus or minus 3 then is one way to show our answer. Realize, though, this is 2 technically different answers. One where it's 2 plus 3. And we also have another answer that is 2 minus 3, which gives us negative 1. Okay, there is our solution for that problem. Now let's just level it up. Let's see how challenging these problems can become. All right, let's just see everything. Well, same process as if you were just to solve. I'm going to add or subtract stuff over. That gives me 21. Okay, here is a spot people might make a mistake. I'm not going to distribute. That's not allowed because of the squared on the parentheses. I'm not going to distribute the squared either. Again, that's not how you get rid of that squared. I just want to move everything over. Don't do too much. Just move things. Do the opposite of whatever's happening. So if the 3 is multiplying, let's divide by 3. If our parentheses are being squared, let's get rid of that. Let's square root to do that. The square and the square root go away, so that just leaves me with the 3x minus 9. And now we can just start to move these values over as well. There's no more parentheses, so now I can deal with these values. Again, when you have plus or minus, just put that value in front of the plus or minus. Whenever you multiply or divide, remember that does affect everything. So x is equal to 9 plus or minus the square root of 7 all over 3. This does simplify a little bit more, but if you leave your answer like that, I am okay with that. But if we wanted to, we could divide these two things separately. We could have a 3 there and there. 9 divided by 3 is 3. Square root of 7 divided by 3 does not divide. So we have our final answer. Okay? Realize the square root of 7, you would try and simplify that as well, just like we did with the 12 and whatever other numbers we dealt with before. But square root of 7 did not simplify, so that one stayed the same. Okay? There's our final answers, though. Yeah, that's the end of our video for 3.3, solving quadratics using what is known as the square root property. Thanks for watching.